Hi, everybody. Just wanted to quickly go over the questions I gave you about misrepresenting data. So, if you look at these graphs here, it says the graphs represent Ontario's grade 3 EQAO reading scores for the school years 2008-9 to 12-13. Each bar represents the number of students who met or exceeded the provincial standard. Um, when you look at the graphs, they look like they're different graphs, right? They look like they're different data, but they're not. They're the exact same data. And this is just a great example of how people can manipulate data to show whatever they want to show. And if you don't pay close enough attention on the other end when you're reading this stuff, then you can be led astray. This graph over here makes it it tries to make it very clear that there's an upward trend. And so it says Ontario reading strategy delivers tremendous gains. And if you look really quickly, you'd think, oh my goodness, look how much it's going up. Whereas this graph over here doesn't look like there's very much of a trend at all. It says government continues to fail our students. The problem is, these questions down here make you think about it, which is great. It doesn't actually cheat in terms of showing data that's wrong. The data is the same. Here, the y-axis is the problem. On this graph, they've zoomed in on a very particular area, 62 up to 70. And so when you do that, the bars look quite different and it looks like there's an upward trend. Over here, they haven't done that. The scale's from 0 to 100. And so it looks like there's not very much of an upward trend. Now, if you think about it, which one is, quote, right? Neither one of them. I mean, they both have problems. Like this one here, zooming in on that particular area without telling the reader that you're zooming in on that area is a problem. That's like cheating. Clearly, this graph would be made by people who are trying to promote the reading strategy because they want you to believe that it's getting better. Now, the thing is, it is getting better. So this over here, government continues to fail our students. That's just not true. The bars are going up. You can see that there is a general upward trend. And so, is this title appropriate? No. Is this one appropriate? No. So neither one of them are really appropriate. There's definite bias here. Again, this one would be the people who want to promote the strategy, and this would be people who don't, right? So you can see, politics would be a good example where I'm just making this up, but let's just say that government A is in power right now and they want people to believe that their program is working, they would put out this graph, whereas an opposing government who wants to take power would say, well, hey, look at this, it's not working. And so in this case, you can see that statistics can be used either way to serve a certain need. So for the question number 2, height versus grade average. This is a good example of a relationship where you could say that there is something there. It says, does a regression analysis support the student's conclusion? What that really means, and I had some questions about what does that actually mean? That means you're supposed to go to Desmos and you're supposed to take that data and you're supposed to put it in and see what Desmos tells you. Now, this is where you have to merge mathematics with your brain. Because when I do my regression, if Desmos ever decides to load here, I'm pretty sure I'm going to see that there's a relationship. Because if I look at the data, the higher height has a grade average that's pretty high, or sorry, lower, and then the lower heights have a higher grade average. So I mean, if I look here, I think it's going to tell me that basically, taller people get lower grades, which I know makes no sense. Let's put the data in real quickly. You can skip this part of the video if you want, because I'm just going to type in the data about my x values, 171 and 73. And then I'm going to have 145 and 91. And then I'm going to have 162 and 70. And I'm 159.81 and 178 and 68. So I'm putting the data into Desmos so I can see it. You can see I can't actually see it right now. I have to get the proper graph settings. So I want my x-axis to say go from I don't know, let's go from 50 to 100. so that I can actually see the points. I'm going to go from the Y. I'm going to go, oh, sorry, that should have been my Y. So 50 to 100 on the Y, and on the X-axis, I'm going to go from 140 up to 180. That'll get me all the data. So I'm just trying to get a window that's going to get me all of the data, and then from there I can kind of zoom in and out. So do you see a trend? I do. I see a little bit of a trend. But doing a regression analysis means I'm going to actually type that in, and I'm going to take caps lock off. I'm going to type in the y1 tilde, and this is me asking Desmos, hey, do you see a trend here? Do the math on it. So Desmos does. This is a very, very powerful line. It says, Desmos says, yep, there's a correlation. I mean, it's pretty strong. 0.814 is a pretty strong correlation, and the R value is high. It's negative, meaning that it's going to go down. And so if you wanted to make an equation, your equation would be there. So if I type y equals negative 0.67 x, or I guess 68x plus 187.37, you can see it looks like the line went away. It didn't go away. It's right on top because this is the line of best fit. So these parameters give you the line of best fit. That's very important. So if you were to base your answer on Desmos, you would say, hey, there is a correlation here, and it turns out that if you're shorter, that means you're getting higher marks, which is fantastic for me because I don't have a lot of height. But what you need to realize is a couple things. A, it doesn't make any sense. This is an accidental relationship. You've collected some data where it looks like you're showing something, but there's just nothing there. If you were, now the other thing is that you've collected 5 data points. 5 data points is not nearly enough to prove something. If you wanted to prove, like if you really thought this was true and you got a little bit of data that proved that that started to show it was true, you would need to collect more data. And in the scientific community, there is actually a certain number of data you have to pick before you can go and say that your results are statistically significant. And this is not even close. So the sample size in this case is a big issue. So for C, how would the student get more accurate results? They would have to get way more data. And if the trend continued to hold, then they might start to go, hey, I'm onto something here. But as we know, they're not going to see anything. There's no relationship here.